Okay, here is the multisim live window. You have to create an account and sign up for an account in order to get access to this. So it's kind of like any PSpice that you run. You've got your elements that you can select. So I can select a resistor. I can rotate it. I can select a capacitor. I can rotate that. I can connect these two. And I can connect this to ground, put a ground here, oops, connect with a wire. All right, so a lot of times my circuits aren't very pretty, sorry about that. All right, let's double click on this capacitor and you can see that I have several options here and I do have the option to set an initial condition. So I'm going to set an initial condition at 10 volts. And then let's double click my resistor here. And you can see I have several options with the resistor as well. And then I have some probes over here. I have a voltage probe, a current probe. Let's look at some of the other stuff I have. I have sources. Um, I have just various things. So if we take my voltage probe and I want to hook it between the resistor and ground. So right now I'm doing an interactive simulation. And let's now go over here to interactive. You can see I have different options. I could do a transient. If I do a transient and I come over here to initial conditions, right now it says determine my initial conditions automatically. I can come in here and I can say that's user defined. So if I come in and user define initial conditions on the capacitance, the system won't use those unless I tell it to. And I have to tell it to under this initial conditions thing here. I can open the graph and do a split screen so that I can see both of these at the same time. And now I will tell it to just start the simulation. And there you go. So basically, here's my 10 volts. Here's my RC decay. You can manipulate the voltage and time axis. So I could change this to 0.003 seconds, and you can see that it ran that. It now shows you if you want it to rerun. It just you have to you basically have to close this out and rerun the transient analysis. So I could restart. So now you see it did it again. So I could come in and I could tweak my capacitor value, and I could now ask it again to rerun the analysis. And you can see it reran the analysis. It changed the time constant. C got bigger, so the RC decay time got smaller. And you can change the characteristics of these graphs. You can change your simulation time. You can do all of that. Right now I have my time range set on my simulation to be from 0 to 0.001 seconds. It shows that because of the values of, it's just kind of a default, but you could change that. So this is just a very simple simulation. I could do this with multiple elements, but basically you can see what you got there. Now there's some other stuff here. I can do an AC sweep. what it's doing when you do an AC sweep is it's basically doing a Bodie plot. I don't have one of my numbers picked very good here, so it's kind of hard to see. Let's see if I can get. Yeah, I'm not really seeing what I want to see, mostly because I have to put a source in there. So I've got to use an AC voltage source if I want to do that. But just so that you know, there are lots of different options you can choose for your simulation. For the transient circuit, which is what we're going to be doing initially, you're basically going to be running a transient model. So we're going to be doing an RLC. You're going to be running a transient model. So let's go back to my schematic. Let's adjust my capacitor value back down. Let's now come in and choose an inductor. Let's put that inductor in here. And you notice it just nicely defaulted there. And let's keep everything the same. User defined initial conditions. Let's split our screen again. Let's do our transient analysis and tell it to start the simulation. And of course, I'm getting nothing because my simulation timescale is off. So when you graph this, you have to be fairly knowledgeable about what this inductor is going to do to things. Let's make sure that my capacitor, yes, it still has an initial voltage. Let's come back here and tell it sometimes on your end time it does not always have a default. Let's tell it, let's go the other way, 1e minus 5 and see what that does. Let's see, that does nothing. So let's go the other direction. Open this transient window again. And let's do 1e minus 2. We'll make it longer. So I'm not catching something. I'm wondering if the way I put this inductor in made it do something weird. Anyway, I'll go back and redo this RLC circuit. Mostly I just wanted to get you familiar with the screen interface and wanted to show you how when you do a transient analysis, you have to come in and set this initial condition as user defined. It's going to tell you it's determined it automatically. That's its default. So you need to go in and physically change the default so that you get what you think you're going to get. You can get rid of this by basically telling it you want to do a new file, and you can discard all your unsaved changes. I believe within Multisim Live you have kind of a limit of number of circuits you can save. You can save these in the cloud. You can save them to your disk. You can take a screenshot. Any number of ways you can document what you've done there. So just you can see there's just a number of things that you can do. Hook up an RC filter, capacitor. Let's loop him. Let's hook everybody up. Put in the ground. It's not liking what I'm doing. Let's connect this guy to ground. Let's put the voltage probe here. will not set an initial condition this time. Let's see if we can get an AC sweep. Okay, so here you go. Here is basically for different frequencies. Here is the output. There's the magnitude, and there's the phase. So this will plot a Bode plot for you, which is something that we will discuss later on when we're talking about how to use this as a filter. But you can see if we take the voltage output across the capacitor, the output is 1, which is basically equivalent to the input until you get to this right here, and then it starts to decrease. So basically this is a low pass filter, and you can see that from the AC sweep, which just sweeps the frequency of this AC circuit from basically effectively 1 hertz or 0 on up to whatever the maximum default or maximum that you set value is.